Hi, all of you. So I welcome to all of you. So am I audible to all of you? Hello,
Yes, audible, sir.
audible. Fine. So let's first I welcome to all of you the second day of FDP. So today is our the second day. So we'll start soon. Our first speaker, Mr. Swapnil, he will join soon for talk. So will before just we are waiting for few more participants join. So then we'll start immediately because today is very less attendance. Oh, so our speaker has joined. So before I introduce our speaker, Mr. Swapnil Pathare, to all of you, then our talk will start. So first of all, I welcome Mr. Swapnil Pathare to our FDP program at IIITG. Myself, Dr. Jana from IIITG, as a co-coordinator of this FDP. So before just I will introduce Mr. Pathare. So he has more than 14 years experience, various industry, Oracle, and many more, and and also specifically Equinix. He has currently is working on, and then he hold his master degree from Indian Institute of Technology, Guwahati Department of Computer Science, and specifically uh, he involved various kind of skill set program, and he has robust skill in various technology, including product lifecycle automation, digital transformations, and microservices, messaging and databases and all. He worked closely with Indian-based Kingsar Foundation for Rural Education in India, collaborations on initiatives in tech, sports and fitness, girls, child education, schooling for tribal areas and more. So just I welcome on behalf of IIITG FDB program for this talk. So Mr. Swapnil Pathare, please start your talk. I hand over to you.
Thank you so much. Am I audible?
Yes, yes.
Okay, thank you. Hello, everyone, and thank you for the kind introduction. My name is Swapnil. Let me share my screen, and we'll see if my deck is visible. Are you able to see a slide that says about me, Swapnil Shekhar Pathare? Members, are you able to see my slide? I'm not getting any concrete responses on whether people are able to see my slide.
Sir, it's visible, sir. Yes, it is visible, sir.
Okay, thank you so much.
Yeah.
Okay, let's get started then. We'll try to make this interactive depending on how much you folks feel comfortable engaging with me. I am a Master of Technology from IIT Guwahati in Computer Science and Engineering, and technology has been a passion since childhood. I have worked with Equinix for the past 10-ish years. Before that, I was in various companies in Singapore. Before that, I worked in Oracle, and before that, in National Stock Exchange of India. So technology segments everywhere, mostly scaling applications, sending them to cloud, thinking about digital experience for internal and external customers, and so on. So my passion is around product security, AI-driven operations, IAM, and building digital experiences. And if I were to look at my leadership decisions, they do not entirely talk only about um, how to build technology, but also about which ones to build versus which ones to buy, and thinking about self-service customer experiences and how to make sales more effective, cost management with various vendors, and how do we optimize cloud costs, and so on. My first principles are craft and own our own destiny, which means that we do not leave our destiny in the hands of another company or a vendor. We do not disrupt customers. We take them along our journey, and we keep learning and we keep growing. So that's about me. If there are any questions, please feel free to raise your hands or feel free to unmute and chat with me. Thank you. All right. So we will briefly hit up on some industry trends and understand where we are with respect to various tools. Right. We are in the age of AI, so I'm going to take AI as an example, but then I'm also going to talk about some other services and cloud capabilities that are prevalent and relevant because my topic is about latest services in cloud. And so one of the principles that we discussed was about how we need to ensure that our future and our destiny is in our own hands. And it means that we are vendor neutral and we are able to build our own solutions with open source capabilities, as most universities do. And we do not want to be locked into any specific vendor. However, the vendors and the cloud service providers and developers for all of these agentic softwares are really in a zone where they want to capture audiences, they want to capture business, and they want to have the critical mass of audiences with them. So every new player that builds a model, even if they open source the model now, behind that is a lot of closed source training, which is made available only if you leverage their systems, right? And so every major cloud service provider now has their own services related to big data, analytics, AI, machine learning, and so on. With respect to that, we have these 4 stages roughly. The first stage is that a new model is established by a private player. This could be an AI agent, or it could be an open source system. It could be a cloud hosting model. It could be container orchestration. It could be anything, right? And so it is disruptive and valuable. That is why competitors like to join in. But soon enough, it will become a little bit commoditized. And now it is not in question where one competitor has a significant advantage over the other. So now companies do not want to have lock-ins. Now they want to have neutral solutions. They want to distribute their workload across multiple clouds. And so they will demand some neutrality out here. And then there will be an open source equivalent that is funded by CNCF or Apache, or mostly driven by one of the big companies themselves. And these vendors set up container orchestration. So these are some of the pieces of very, very sophisticated technology which are available in open source. An example of infrastructure setup is the Terraform scripts that you can write to build your entire infrastructure, and it would be used across clouds. An example of container orchestration is Rancher and Kubernetes, right? And K8s does pretty good container orchestration, I would say, given the level of efficiency that it can achieve and the granularity it can achieve. The number of pods that you can set up, the elasticity that you can set up while doing this, whether you are doing it on premise with your own rack and stack, or you're doing it on cloud with a vendor managed solution. Right? Object storage, I would say object storage first popularized by AWS with S3 has become sort of a common standard across the industry, with many providers bringing in object storage as well. We have continuous deployment, which brings in everything from Jenkins to GitHub Actions. There are a lot of standards around continuous deployment. And vector databases, once considered to be the darling of aggregated retrieval and generation, augmented generation for retrieval and so on. Now, these vector databases, you have Postgres plugins as well, which offer you vectorized information and indexing over your data. So many of these tools have achieved some sort of maturity, and there are many equivalents available in the industry. There are paid services, absolutely, but there are open source services as well. The AI agents and big tech for big data, like that is really right now in a place where there are individual performances by these industry players, specifically like Azure and AWS and GCP are at very top of that, but Azure and GCP have sort of a lock-in on who gets a better, I would say, AI foundry setup, AI factory setup, where they can allow practitioners to come in and create AI agents and then interact with other AI agents and so on and so forth. So it is a very promising space. However, it is still very closed source and a very vendor lock-in managed area. I would not imagine it is trivial to take AI agents and models that are built on one area and then move it across to another cloud provider. Right. All right. Because I work with Equinix, I have this one slide which talks about what Equinix does. And we are a data center provider, and a data center provider is an infrastructure. It is to, if you are thinking of very sophisticated cloud services, and then you are thinking where does Equinix stand in those cloud services? It is equivalent of saying there is Facebook and WhatsApp on my apps on my phone. Where does Airtel stand? Airtel is the service provider. It is at the bare bone network layer, which is allowing you access to data through 4G and 5G, which then allows you to access these services over high performance, secure access, where nobody can more or less snoop in or understand what is the communication that is going, and you can have end-to-end private connectivity, but with I would say a pretty reliable network, even where we were 50 years ago, a very reliable network, wireless network spread across villages and towns. So Equinix is somewhat of that nature in the B2B space. We are the data center provider. People come with their rack and stack, and then they get private, high bandwidth, low latency cloud connectivity to various cloud service providers, and also to their other branches. Right? So let me see if I have a diagram for that. Okay, perhaps I don't. So this is an example of a company trying to connect and bring their rack and stack into Equinix and trying to connect it to cloud. So you have two cloud providers, and the use case is that of hybrid cloud, because with the Am I still audible, people?
Yes,
Yes, sir, you are audible.
Thank you so much. Right. So going ahead, right. Let me get back to my share. All right. So we are coming back to the zone where we started, where with a typical company's growth and maturity, I will say. We can take an example of a fantastic service provider like Netflix, or we can take an example of a more bare bones service provider, any enterprise company, ABC, right? And so ABC wanted to get going with its platform and its services to its customers. And so they just went to AWS and started creating their services out there, right? And as they became successful, if they have to prioritize the go-to-market time, which is like they want to do it in months rather than in years. So they don't want to wait for infrastructure to be set up and so on. They just want to go on demand and go cycle around that and go fast on creating the value for customers. And so as they went there and they created that value, and if they become successful, soon enough they will realize that their infrastructure bills went up. They were using capabilities that were pay by usage and not really a fixed cost per month. And so now they will try to improve on that architecture, right? And if they are a really critical service, then they will also realize that any AWS downtime affects them because of a misconfiguration of AWS network or so just brings their service down. And this has happened with many cloud services over the last few years. I think the cloud services still provide a fantastic level of reliability, but failures can happen because human errors can be brought in. So to avoid that, they decide to spread across their architecture. And so this is the architecture which evolves for a maturing company. Right? And they will bring some rack and stack, they will put it in a data center. I'm just using Equinix as an example here because I got the diagram from Equinix. And then they might have their services across two clouds. They could have a database tier in cloud service provider 2, right? And they could have their compute tier or a web tier in cloud provider 1. Now, why is the database separate from the web? Now, database could mean that you could then use this transactional data to process into analytics and then drive your analytics and business intelligence from there. You could drive your AI agents and understand situations from there, and so on, right? So this is where the maturity of the architecture comes in. I'm sorry? Okay. So this is where the architecture becomes very valuable. Good. So let me go ahead. Okay. So what are the considerations which you will have when connecting to clouds? And then from here, we will dive into what are some of the other things that we want to talk about, right? So considerations when connecting to cloud will be performance, security, the data center costs, and the cloud service provider costs. Performance is measured by whether your pipe to the cloud is wide enough. If you are having terabytes of data that are being flown across the pipe, across maybe by the hour or by the day, then do you have the redundancy and do you have the connectivity with multiple virtual circuits to cloud? Security will involve, like, are you going to have an IPsec over your connectivity? Because this connectivity, this red line is not completely secured. The red line between, it is a physical connection, but the connection from the Equinix router to the cloud router will be over a wire. And so if you want to add end-to-end security, then you would want to implement some level of tunneling and choose the devices accordingly. Costs will involve some costs which you bear for Equinix. If you were going through the internet and you would be paying for the hops that you made as an enterprise customer, then the cost would have been equivalent. Perhaps Equinix will still result in fewer costs, but they have to be inculcated in your evaluation nonetheless. And CSP costs, more or less everybody is aware that data egress costs, right? So if you have a cloud service provider 2 and you are going to move that data through any channel into cloud service provider 1, or use it outside of cloud service provider 2, then the cloud 2 is going to charge you for data moving out of their zone. But if you use the services entirely within cloud 2, then they will not charge you for data moving outside of their zone. So there are nominal network traffic charges within cloud providers, but egress of data is charged pretty heavily. So that is to be brought into consideration. All right. With that, let me talk a bit about some of the cloud tools that are prevalent today and what makes them valuable. Okay. Let me get started with something called BigQuery. Give me just a minute. Okay, some processing is going on my PC, and I apologize for the wait, but we'll get there. Okay, maybe we keep the query for later and I get going with some other use cases. All right, let's talk about AI and where we are with respect to AI. We all have of AI across the last few years, and every month brings in a new capability and something exciting. It started with large language models. Large language models were superior to earlier models which were doing data interpretation. It democratized the way that we could interact with the systems and ask questions of it. And large language models were mostly based on this fact that there is a language interpreter who can understand the tokens and understand the intent of the question, and then go back from its memory, understand what data it has with relevance, and then showcase. Right. From there, we went into, we have a large language model, but we don't want to train it with all the world's data at the start, and training is expensive and time consuming. So we wanted to retrieve based on some information, and after retrieval, it can generate the answer in natural language and respond to the user. And beyond that, we went and said, no, actually, we don't want just retrieval, because retrieval means that there is data that is vectorized and kept. And so we want some agentic workflow which can come in and then start working on the query and do the operation as well. So this is where we are getting into very interesting territory, where perhaps the future of every sector is interaction by large language models, and you are not going to a web or a mobile interface and tapping buttons and clicking anything anymore. You're talking, and you're talking to computers, not to people. So where are we on this sort of journey, and where does the industry sit? Right? That is what I'm looking to cover today. So let me share my screen again. All right. I expect my Chrome tab is showing up again. If not, to let me know. Cool. So let's talk about where we are, right? So in around like last year, this time, we had roughly 2 to 3 models, and each of them had a range between capacity, capability, and efficiency. Right? And where we are today is simply astounding. We have got tons of models. I should add a caveat to this by saying that I detest making my own slides, because there are always more beautiful slides present from some other providers. So I steal slides from other places all the time. These are slides from Azure AI Foundry themselves. So I'm using them to get across my point. As much as I am a little bit conservative about getting into vendor lock-ins and using vendor native capabilities, I have to admit that for AI, there is no better way right now than vendor lock-in. The capabilities that are provided, the integration that is provided is simply phenomenal. Right? So we have come to a place where we don't have just GPT models, we have got Claude models, we have got Gemini models, and then we have got competition from several other models like Llama and DeepSeek as well. And we have a pretty dense, I would say, lay of land in terms of which tool you select. So there is definitely a tool explosion which will need to be managed, because there is simply too much information and it's very difficult to choose a tool of choice. So we'll get to how we can improve on that later. And so fine-tuning is becoming critical, because out-of-the-box models are not going to be entirely useful. And training your own model is even a more time-consuming piece, and it requires deep expertise in ML. So the model that is chosen by developers now is take an existing model and fine-tune it. provide it instructions, provide it context, and provide some tools to it which will do the work, overall reduce the amount of hallucination that might happen. Do not have the LLM do everything. Let the LLM outsource to a tool which will do some retrieval, which will do some operations and come back with an answer. Then LLM will talk to it and progress the state. And so, where we were yesterday is there was capability to repeat tasks, and there were assistants who were there to answer questions. To this day, I am still using assistants in the model of ChatGPT and also my Copilot in my IDE, right? So everything, if there is definitely a productivity spike there, I'm able to churn out some applications and some utilities at the speed of roughly 4 to 5 people, even though they are for personal use, so I don't go through the entire productionizing capability. But if I'm building, in my company, we have now a level at which we mandate 25% of code contribution to be happening by Copilot, right? And that is just, it is called as a mandate, but it is a suggestion, but we find that already people are able to contribute much more than 25% by Copilot. So assistants are here to help. There's no question that productivity is improving, and I hope that all of you have played around with assistants in your time, agentic assistants, I would say LLM assistants. But what is happening now is not just a question answer model where the assistant is able to answer your questions, but agents who are actually able to reason and act on those statements, right? So understanding an intent from a person and converting it into a task and then calling an agent is all the responsibility of an LLM. And now the agent is able to take it and actually perform the task. So a good example here is complex tasks like onboard 5 employees by Monday. But that onboarding requires access, it requires hardware, it requires system setup, it requires entry into several places, it requires updation of funds and budget systems and so on. And so there is a lot to do. And now in place of probably 10 human beings who are required to do all of these tasks, you can have them focus on more higher value tasks while the agent is doing these tasks. And so the humans, that there are obviously 2 ways of looking at this. Are humans being replaced or are humans moving to a higher value chain? My take is the latter, that humans are moving to a higher value chain. However, there is no question that we also have some layoffs in the industry which point to otherwise. All right. What this has resulted in now, I have somebody unmuted, I'm not sure who. All right, thank you. Okay, and so now we have an ability where the demand from a solution is no longer the same demand as it was 2 years ago, and that itself is a phenomenal change of mindset. There is a shift in expectation. I have been using pretty much like all of us around 50 tool sets, depending on what we aim to do. And each of those tool sets, the demand on them has increased, or the expectation from them has increased. If we were recording Zoom meetings earlier, now Zoom comes with a built-in transcript generation and a summary generation. That summary generation can take a sentiment analysis of the meeting as well as the action items from the meeting. So there is an action items list that is auto-generated so that the human doesn't have to work on it. There is a meeting summary that is generated, but there are chapters in the meeting that are generated which talk about what each area that was talked about, and it automatically determines how many areas were talked about. It understands whether there was an agreement or a disagreement on a particular topic. And so now you can take this and put it in Jira and literally have Jira converted to a requirement. You can go to a Confluence page and challenge the Confluence page. This is an Atlassian tool. You can go to a wiki page and ask questions around who has written information around this particular topic, at what time was it written, and how many times has it been refreshed, and it will give you all the answers. And so the expectations from a wiki are not the same expectations that were there in 2023. The expectations from Zoom meeting recording agents are not the same as if they were in 2023. It is just several times the expectations have increased, which just goes on to show that we are not building the same software as earlier. Has got an agentic piece. Some of it is to actually just promote the software, but some of it is really, really meaningful. Right? Going forward. So what is an agent, right? We have the constructs of LLM, which have been around for a couple of years now, and we have instructions that you can give to the LLM, and we have tools, right? And the tools are there is a variety of tools available. Sometimes they are called AI services, sometimes they are called tools, but these tools specialize in some area, right? There is a tool that specializes in summarizing content of long form. There is another tool that specializes in maybe content generation or code generation. There's another tool that is very effective at image analysis. Right. So these tools can be called. Now the onus is not on the agent or the LLM to do everything. The LLM is now supported by tools. So this is a very recent architecture, I would say, compared to maybe last year. Excuse me. Maybe last year when we were all on LangGraph and LangChain, and the expectation was that LangChain will go to LLM and figure out what is to be done, will come back, will invoke a tool if required, and it was a sketchy implementation at best, I would say. It was among the most stable implementations, but still it was work in progress. It was not really production ready to the best extent. And now with this framework, which is an agentic workflow, you can have agents talking to tools, you can have agents talking to users, and you can have agents talking to other agents, which is sometimes referred to as A2A. Specifically, I think in Google, there is a reference to A2A, which is an agent-to-agent communication. And the interesting piece is any tool that is built with an API interface, now you can have a specific protocol that understands how to call that API just by looking at some documentation. And that interface is now open source. It was created by Anthropic. And the name of the interface is, of course, Model Context Protocol, which understands how to take a specific request from an LLM and how to translate it into an API of a downstream system. Right? And so let's go a little bit about where we are and what agents are doing, right? So agents are building software. They are getting value from data. They are solving complex challenges. Let me know if there are any questions on agents and their purpose before we go ahead to how Azure Foundry is solving them. All right, largely I feel most of you have understood or have already been well versed in the way of agents. So let me go forward. So we'll take some use cases later. Perhaps we can go forward to where the models are going towards, right? So we are going from writing extremely deterministic pieces of code, if that for loop conditions, so on, to building probabilistic code. And probabilistic was considered to be a very research-oriented piece that, oh, you build this only in the research segment, in the actual production segment, you write very deterministic stuff. So now we are moving from deterministic to non-deterministic, and we are allowing AI the option to explore and respond just in time. But that requires some level of checks and balances. So we'll talk about those checks and balances as well. All right. Yeah. So now with the newer capabilities, what are the main challenges that are present in the industry, right? And so many of the generative AI systems and technology that is getting built, the actual value to customers, does not find the confidence to go live and be generally available. It might be a closed beta, it might be an open beta. People are a little bit still considerate of the fact that AI can hallucinate, AI can make mistakes, and then there is a legal liability on the answers that it gives because we are saying that this is a chat for you, dear customer. And so there is a legal liability. Now, how do you improve on this concern? Because that is available, but the legal liability prevents you from leveraging the disruption and making the most of that business, right? So one of the first things to look at is model selection. There are several important already developed. There is DeepSeek, ChatGPT, and there is Gemini. But there are, depending on your use case, there are hundreds of open source models on Hugging Face. I'm sure some of you might be today contributing to models for Hugging Face as well. So Hugging Face is a marketplace of models, and many models with many capabilities are present on Hugging Face, and anybody can come in and use them. The next is how do you execute complex workflows? Like an LLM, doing the work of an LLM is understood well and clear, but an LLM connecting to a tool is already a new thing in the market. Now, an agent with these capabilities, which has got LLM and tools, how do they connect to another LLM is another matter for understanding and for ensuring that there was a tracing available throughout it. Observability and governance come into place also, as I described tracing. And then there is content safety. Is the content that is getting generated safe? Is it respectful? Is it does it answer the query without opening a Pandora's box or creating anything controversial? So that is content safety, right? And so these are challenges around today's development of systems. So let's take a look at how an AI app development gets done, right? So we are building an agent at this point, right? And so the agent has got a prompt and a model. The agent is using an LLM model, and then there is a response. That response will then run a code, and then it can feed back to that agent who can improve on that with the prompts, or it can respond, right? So the important thing out here is separation of tenancy. If two users are asking different questions to the agent can understand both of them, but it does not confluence those queries, and it is able to have a separate understanding of each query, and it is able to serve each query by itself without intermingling them. All right, and then what developers need is specifically an ability to prototype quickly and to experiment quickly. I think some of the tools that have come up over the last couple of years really address these, but there is still room for improvement. For example, at a recent Google I/O conference, it was declared that you will not have to go to the Vertex Studio and get a quotation. You can literally go into Vertex Studio and start developing AI agents. Now, this is compared to last year where you have to go in, you have to talk about what you want to do, how much of capacity you might need, get a quotation, and then get started. Whereas Microsoft went the B2C way, Microsoft, you could just go in and self-service, get started with the project. Cool. So with that, let's take a look at Microsoft AI Foundry, right? So Azure AI Foundry is a place which is in Azure Cloud, and it just brings in the number of components that are required to drive creation of AI agents and interaction between AI agents properly. So it is all right. I've muted a couple of folks. coming back. So Foundry is built with an ability to interact from an IDE. So you have the IDEs on the left. Right? Foundry is also built with an ability to connect to many cloud services of Azure. This is an Azure service, so definitely, other than the model, I believe Gemini is included to some extent, but other than that, it is mostly integrated into other Azure capabilities. So it is meant for cohesion with other Azure services and also for a lock-in of customers, which I have already established that I'm a little bit skeptical about. But that is where we are. These agents allow, these services allow really fast development of agents and an ability to bring those agents to production. So I think pretty valuable out here. On these specific components of Azure AI Foundry, does anybody have any questions? All right. So before we go ahead with an example, let me just talk about the security and governance piece, right? And so there is a very interesting observability and governance piece for Azure AI, which is how to test the efficiency of your AI model. There are two capabilities out here which you need to test. One is whether the model that you've chosen is appropriate for the agent, or is there an equivalent model? Maybe instead of Gemini, you're using Claude, or maybe instead of Claude, you're using DeepSeek, and then it results in a better answer. This is something to be evaluated. And the second is whether the answers are relevant enough, right? And so both of these can be done by manual testing or automated testing. Automated testing is a way in which you build your use cases. You throw some, it is basic training, whatever we do in ML, the 20% of data that is reserved for training versus 80% that is reserved for, 80% that is reserved for training versus 20% that is reserved for testing. Here also, there is some data that you fill in earlier, and you have pre-generated an answer which you found best in the scenario for the question that is asked. And so you are checking if the agent can give an answer close to that. So you are refilling this test information, and an automated run can be done perhaps every day or at a regular cadence to just understand whether you have got equivalent responses, whether the agent is having a distraction from the norm, has it learned something else which is not expected, or is the agent true to its zone, right? So that is one way of testing it. The second thing observability brings in, because of integration, now this is a big advantage. At the production level, the industry engineering teams are very, very concerned that it is not just about building and delivering capabilities, but also about ensuring that when actually problems occur in production and customers are complaining of something not working as expected, they are able to find the root cause. It is probably not a practice in the last 1 decade to go back and ask the customer, can you tell me exactly what you did? Like that was something that technology people used to do earlier, but now you need analytics. You need sometimes session replays to know what the customer did. You need incident reports. You need an ability to search through logs and traces. And so observability has become a very big word in the industry. So Foundry observability, AI Foundry observability actually provides you traces throughout all the agentic calls. So if you call the agent using a Postman script, using curl, and then the agent is calling the LLM, it is getting the information from LLM, then it is calling a tool, then it is getting information back from a tool, then it has delegated to another agent, and that agent is also working across another tool. So this flow for this particular request ID is captured, and it is available to be seen through the Foundry observability, which is very, very important. I do not have a demo available right now, but perhaps we could go through it sometime, right? So very, very mature service, I would say, and it is spectacular that you get this sort of observability baked in. If we start building open source stack, and now that open source stack has a database and it has agents and it has got some Python scripts, and it has got an LLM that is trained locally on several pieces of data. It has got a vectorized database. It has got retrieval augmented generation. Now, to actually find where the request went, you would have to apply an observability across all of these pieces. Then you would have to move that data reliably so that that data is not lost. You would have to have great network connectivity, and you would have to move it to a system which had got, I would say, a great write performance. And then if you are using an elastic stack, for example, to fit that data, then there is questions on sharding the information and making sure that one of your clusters is not overworked, the primary is not overworked. And so overall managing all of that is very difficult. So observability is a piece where SaaS tools really shine. And so I would say Splunk, Datadog, and other tools which really take the model of whatever is expected for observability and drive performance on top of that, multi-tenancy on top of that, IAM on top of that, and then the visibility, the visualizations, the ability to drill down into a particular segment. Those are key. And so Azure AI Foundry brings that to you in a completely out-of-the-box way, which is phenomenal. So all of the piping, which takes sometimes months to build and to test and to take through to production, gets saved here. But there is a cost associated with it. All right. So let me find if I have a slide that talks about the use case. All right. So we have a use case here at Equinix which talks about incident management, right? So how do you take a production issue where there is either a service health problem, or there is a query from customers, or there is an incident where customer is not able to get what they want, and so they have escalated something. And so the engineering team is a small engineering team, and you still have to support customers across all regions, and escalations can come at any time, and they could be in multiple formats. So now there is a team that is representing the user or the user themselves who can write to a Slack channel saying that I have this issue, and they pass a screenshot, right? Now that screenshot contains an incident number. Now one of the first things that this bot is just a black box for agentic software that is written in Azure Cloud Foundry, and this is multiple agents and tools, multiple tools connected to one agent, right? So there is an orchestrator agent who takes in this request. There is an agent who extracts the incident number or the correlation ID from the screenshot. There is an agent that connects to past tickets. We work on software from Atlassian called Jira, and so it goes through Jira. It goes to past tickets which are of this nature and looks at how they were resolved, whether there was any manual steps that were done, whether there was any data correction that was done, and brings it back to the site reliability engineering team, saying that these are some of the ways that in the past these sort of issues were fixed. And there is another tool that goes to the observability. So it goes into Splunk, it goes into Grafana Cloud, it goes wherever our tools, software's observability is centralized. And it goes and finds the traces for this particular correlation ID. It finds the logs for this particular correlation ID, and it finds where the errors occurred and at which software layer it was. So we have digital experience, we have IAM, we have a cache of information, we have enterprise systems at the back, we have a case management system, which is a SaaS tool. So there are multiple diverse systems, right? We are working off probably 100 plus tools at this point of time to get customer the full experience while giving business the tools that they require to take the business forward, right? So there are sales tools, there are finance tools, there are revenue operations tools, there are taxation tools, there are customer order management tools, there is tools to understand what are the customer requests and solve for them. So many tools are there, and now you have got one customer who is saying that something didn't work, and it could be in any of these tools. And just to have a set of bots going through past challenges and then going through current information and observability and getting back the response in less than 2 minutes, like that is something that no human could achieve ever before. Even if you put like 20 people always 24/7, 365, they would not be able to get this much information back in 2 minutes. So there is no comparison that we are creating enablers and we are creating accelerators, right? There's nothing that we could have done with humans at this scale. And this is just for one incident, right? Several incidents of this nature are coming in. And so this goes back to our architecture here, right? If you are building a capability out here and you're using agentic workflows which allow you to nest multiple agents, those agents can understand the query and understand images and are able to use those images effectively. Then they are given a set of instructions on how to process those images. There are specific instructions written in the input as well as in the agent's creation itself, right? And then they are able to leverage the tools. The tools can be retrieval. Now, this particular retrieval that I was talking about went to the observability stacks and retrieve. Another retrieval tool was specialized towards Jira and understanding of how tickets were solved. So the two retrieval mechanisms are very different, and so they are handed over to different tools, right? And that means that the chances of hallucination become very less. And now the agent is able to just understand based on the description of the incident, the description of the tool, it is able to delegate to one or more tools and get back the answers. A separate scenario out here is how do we get customers to interact with natural language? And so the customer comes in and, for example, asks, I've placed an order yesterday. If my order is fulfilled, I would like to visit the data center tomorrow and check whether it is functioning properly. And so now this is a very loaded statement. This goes through not less than 15 screens in my today's application. And so we are building this application for tomorrow, and I'll just take you through what sort of tooling is required here, right? So number one, we have to understand the intent and the tokens from the customer, and that is the job of the LLM. So the LLM is taking these statements. I have placed an order yesterday. So now you have tools, calls, and how those tools call, right? So going back to this specific diagram, if a customer has asked this question, not on Slack now, but on the digital experience of Equinix, then the bot is going to take the intelligence, which is the LLM, and is going to go to Vault to develop an understanding of which keys to use for retrieving information that is asked by customer. And so now the customer has talked about specifically about, I have placed an order yesterday. So this is a user, there is a token because of which that token is, the web session is working. And so take that token, and now you are free to hit a multiple APIs to understand what the user is doing. And so placed an order yesterday means that there is a order history API that talks about what orders were placed, and you can filter by date. And so you can put the date between day before yesterday and today. And so you can time bound that order because he could be in any time zone, and yesterday could mean a number of things depending on whether he's in Southeast Asia or whether he's in Western Europe or Western Americas, right? And so it is very dependent on their user preferences, their location, and what yesterday really means. So take that, bound your query, understand what sort of orders were placed yesterday, which were orders inside the data center. And so now, based on that, retrieve orders and understand whether an asset was created. Yes, indeed, an asset was created, and that customer has been provided with some tools and some hardware inside the data center from our side. And now the customer is saying, if that is present, I would like to visit the data center. So this order was requested for a particular data center, maybe New York, maybe Frankfurt, maybe Singapore, maybe Mumbai. And so depending on where the order was placed and where the facility got delivered, create a work visit ticket for the customer to come in and put the date as tomorrow. So give a range saying that they can come from tomorrow midnight to day after tomorrow midnight, and create a ticket, create an order or a service request that says that this customer, this specific user is going to come into the data center at this time, and that shows up on the security screen of the data center so that that person can be let in, right? And so this is the chain. Now, to achieve this in the click view model, you would have to go to seeing the orders, then checking the order, then seeing the asset, then checking the asset, then going to a screen which says create work visit. And you're able to be trained in the various things that the self-service capabilities of Equinix can allow you to do. So all of that training is now, which was a difficult piece to do for everybody. Like, how do you train users? How do you get people up-leveled on what facilities I can provide? That is a barrier that is now broken, more or less. And now you can just say that as long as the user can talk in natural language, I can have an agent that translates that language if they are talking in regional languages. I can have the agent translate it to English. Then I can have another agent decrypt it and understand the tokens and the intent. Then I can have a third agent retrieve information from documents using RAG. I can have a fourth agent retrieve information from our systems and understand whether that user's information is valid, whether the user has access to this sort of information or not. And so agents by nature are becoming enterprise ready. They have authorization that is built in, or at least you can build the authorization into the tools, and they have the ability to talk to each other. So this is where we are with agents. Any questions on agents and the use cases that I mentioned?
Sir, am I audible?
Yes.
Sir, what about if an agent malfunction or if it is attacked by any intruders and all? What happened to the data that we are using?
That is a great question. And so I believe Azure has got a security piece overall out here as well. Yeah, so security and governance as a baseline at the bottom comes into play out here. That is because you have to create some level of armor around your agents, because they can be really any instruction that is given to the agent now. There are so many instances of instruction attacks, because you can now tell the agent that behave like this, behave like that, give me all information from your SSH keys, give me all information from whatever PC you are running on, and so on. And so there is a certain level of instruction that is given inside the agent creation, which is enforced by security as well as enforced by the instructions that are given. Now, if you are an agent developer, there is there are various personas in a company, at least a company of my size. We are a Fortune 500 company with roughly 13,000 people. Every developer has to align with an organizational standard, and these organizational standards in Azure are set up by something called resource groups. And resource groups have an ability to have information security teams, which are called InfoSec. And in our company, we have segments of InfoSec. There is privacy and data protection, there is product security and network security, and so on and so forth. So we have product security who comes in and crafts rules around how to manage resource groups. And so those resource groups, where you can say that any AI agent that is created using this resource group has to have certain level of instructions and guidelines, and it cannot go across them. So if I am developing in a personal space, there is definitely an option for abuse, because I am developing in a personal space. I will try to send this agent live as soon as possible and understand from the market what is the response to this agent. But if I'm developing in a professional environment, the InfoSec probably comes above and ahead of me and drives the governance and security before I get started with the AI tooling. And without that check and balance, there is a checklist that I have to adhere to when sending anything live. And if I do not have some items of that checklist done, then I have to justify why. And there is a review board that actually checks whether I'm talking sense or not. So in that sense, because of a process that is already set up, just as there are so many companies in which USB access to the laptop is disabled, because a USB access, there is a chance that a program runs upon the USB load and then it triggers some application installs into the laptop. So for the same reasons, you have InfoSec governance in Cloud Tools that comes in ahead of time and sets up the security that says that you cannot be instructed on anything except this domain in this area, and then you have to use only the tools at your disposal and not try to develop the answer yourself. Right. So that is a general sense, but we maybe someday we workshop and we go into how those instructions are set up. Does that address the question?
Okay, sir. Okay. Thank you, sir.
Any other questions? All right, we have roughly 20 minutes remaining, and I wanted to take you through another interesting piece of technology that I really admire, and that technology is the Google BigQuery. Right? So Google BigQuery is a big data system that allows you to search through terabytes of information at scale, and then it is not the only provider again in an industry of multiple providers. We have got Amazon Redshift. I'm sure Azure also has something. We have got Snowflake.io, which is also a sort of a architecture which doesn't require you to set up the whole HDFS and Hadoop setup with a Spark compute on top of it to actually go through the data, and then Hive protocols or any other protocols that really get you the insight of the data. So this is creating simplicity, but managing all your infrastructure behind the scenes. So let's look a bit about like what it solves, right? It solves in a columnar data fashion, which is representative of several columnar databases like Cassandra, right? So it uses columnar database, but it allows you a very SQL-like query pattern over that data, such that you benefit from the decades of SQL experience and expertise that many people have, and you can still afford to migrate your data to BigQuery and search on that. So among the many things that people look for in clouds is cost optimization, because cloud costs can go pretty high. And so the expectation that people just want to solve the problem is not valid. People want to solve the problem, create security, and then have minimal costs, right? So financial operations are a major struggle, and there is always a team dedicated to that if you have enough of cloud spend. A very interesting piece from 37 Signals, which is a very prominent company, I think among the most valuable companies given as per engineer revenue, very, very high. But this company moved out of cloud over the last 1 year, and they reduced their costs by 90%. Even accounting for amortization of the hardware that they purchased and the data center space that they purchased and so on, they estimate that their costs reduced by 90%. So definitely when you are using cloud services completely managed, you do not have to think about upgrades, you do not have to think about patches, you do not have to think about migrations. Everything is managed internally. You don't have to think about high availability and fault tolerance because it is all managed by the provider. It really allows you to create fast value. However, there is a cost associated with it, right? And so let's take a look quickly at what Google BigQuery really provides us. So you have got block storage nodes here, which are called Borg, and you have got Jupyter, which allows for like petabyte level connectivity. It is a very, very highly distributed networking system that connects nodes. And now the final piece of the puzzle, your compute nodes are separate from your storage nodes. And so if you are storing the data 90% of the time, but computing on it only 10% of the time, you are mostly paying only for storage. Right? And if you have storage, which is relatively, I would say, limited, but you have a lot of analytics going on that, you are paying only for compute. The storage is cheap. Right? And so you have got a general sense of you are spending only for what you are using, and you're not just spending on the whole piece together. Whereas if we think about any server setup, you would usually have a simplistic server setup would have compute and storage in the same place. But even if not, you would have a rack which is distributed into computing and storage. But now you have limitation around hardware. You cannot scale at will. And so this is where you can scale at will. If your data grows from gigabytes to terabytes, went from 100 GB to 1 TB, in a span of 2 months, you're totally fine by it, and it does not affect your performance very hard. Right? And then comes the tuning, then comes the performance improvement, then comes how you can improve the query set, how you can change the query sets, and so on and so forth. So this is the core capability in BigQuery. But if we go and look at the components in BigQuery, you have a BI engine, you have got query execution. These now query execution comes with stored procedures and user-defined functions. It is very representative of what we do with SQL databases nonetheless. And then you have got machine learning and remote functions. Below that, you have got security policies which restrict the access at this level. At a very low level, you can talk about who is able to access what sort of information, and not all information in the database is accessible by everybody. The analytics hub that is mentioned here is actually called, so there is an analytics hub separate, and then there is also a charting library called Looker. Looker is a self-service charting library that Google acquired from some third party, and it has really made big strides in that in the recent years. So you can perhaps take some time out to look at recent Google I/O, I would say, declarations and releases on what they have done with BigQuery and Looker. Overall, they have democratized much of it for self-service. You can craft really beautiful presentations and informational outcomes, talking of geospatial setup of data, heat maps, country level maps, all of that, compared to what was available in the previous years. And then now you can, on top of that, you can, with good indexing and fast retrieval from BigQuery, connect it to Looker, where you can craft these beautiful visualizations. Right? A big lake is basically storage, which is, I would say, representative of how the Hadoop file system was present, and HDFS was set up. It was a distributed file system. It could go through multiple nodes. It would have built-in replication, and so it had protocols and capabilities with which you did not have to yourself code for every piece of redundancy and fault tolerance that was required. It was built in. So Big Lake Storage is based on that. It is based on the Colossus file system, which is based on, I believe, the Google file system of the early years, and it has just been built into this capability from where you can now run. Now you can store in a distributed fashion. Sharding is taken care by default, and then you can run BigQuery compute on top of that. Every BigQuery that you run talks about how much data was retrieved and used for this query. And so if you can tune the query, it really shows like the data retrieval went from gigabytes to kilobytes sometimes, because you were looking only for a couple of columns. Because it is a columnar data store, it can retrieve information only in those columns instead of fetching whole rows, and that really improves the capability. So this is BigQuery. I unfortunately do not have a demo to go through it right now. I wish I could find the time to build a demo, and perhaps some other time. I will, as a last update, take you through what Google AI has done in Google AI Studio. I'll share my screen again. All right. Is my Chrome screen with Google AI Studio tab visible? Anybody? I'll take that as a yes. All right. So this is some work I was doing with. Anybody is responding? Okay, cool. So we have got a code assistant out here. I have set as a user I want to build an AI agent which scrapes GitHub repos for projects with the description provided. So this is the entire piece of code that is written here, which could be done with Copilot or Visual Studio Code as well, has been done by this code assistant, right? So it went, it understood what was to be done. It thought for 41 seconds. It designed the React app. It mapped the application logic. It redefined and refined the architectural blueprint, understanding how to leverage the Gemini API out here, and what sort of capabilities you need in the UI. It conceptualized the API interaction and what needs to be sent to Gemini and Google Gen AI overall. It conceptualized it implemented the Gemini integration. It already had the Gemini API key from me. It structured the API query. It created the prompt for Gemini. It implemented the search logic, and then it figured out how to display that at the end. And so it went through iterations of this. It crafted more prompts. It crafted better architecture, and it iterated several times over this, overall giving me this preview. So this entire piece of code that it has generated, the preview looks like this, right? So I had asked it to build an agent, but this is not a place where you build an agent. This is a place where you can build a tool, right? But it is a place where you can create a beautiful front end, and you can see how your model interactions are coming into action. You can play around out here, but it is not the place to build an agent. The place to build an agent is Vertex Studio, and it is still being democratized. So you can go to Azure and build an AI agent, but you can check what is happening here. So now, describe the type of project you are looking for. This is the GitHub Repo Finder AI, and so I want a project which has a Python code base and recognizes text from images. So I find repositories. This is sending the request to Gemini. Gemini is hitting up an agent or a tool that goes to GitHub and retrieves information from GitHub, brings back, and it has a beautiful painting. So this is more or less a customer-ready application. I think some session timeout might have happened here. Okay, it found. So you have got a Python wrapper for Google's Tesseract OCR engine, recognizing text embedded in images. So it is now using the description of those projects to fetch back the most valuable projects that you need, right? And so this is an example of how fast AI can drive your capabilities and create value. This is what I had for the latest cloud technologies. There are several hundred cloud technologies that are available today. Unfortunately, we won't be able to cover all of them, but I just wanted to take the time to really focus and go in depth on the use cases of one or two. One is accelerating development and enabling newer capability of interaction, which is the AI, and the other is creating insights out of analytics based on a lot of data, structured or unstructured, which is the BigQuery. And so that's my time, people. I'm happy to answer any questions if you have.
Any questions from anyone else?
Hello.
We eventually got a lot of people attending, but perhaps.
Yeah.
No
Sachin, I have a question for you.
Yes.
How to manage the scalability of this managing agentic AI systems?
So because it is present in the cloud, the scalability is managed in the cloud itself, but it spikes up the cost quite a bit. And so the real challenge is to how do you size this? If you were to use open source capabilities like LangChain, right? And you were to build this on your laptop, and now from here you want to take it to production, but put it on your own infrastructure, not inside a cloud. So now the question is, how do you size for this? So there are formulas that are present which allow you to evaluate, and there will be performance tests that you will do, of course, to see the number of versatile requests that this agent can manage. And then based on that and based on your target audience, you will obviously start small, but then you will have alerts being driven from, if you develop some service level objectives that I want my AI agent to respond within 5 seconds of the query for every customer, and the maximum number of users that it should be able to accommodate is 100, that is the load test that you will run. And as you find alerts and indicators that you are straying away from this objective that you have set, which is that it should respond in 5 seconds. So your 90th percentile request says that you responded in 15 seconds. That is when you know you have to ramp up on either the GPU capability, or you have to ramp up on the database storage or the indexing change or whatever. So you'll have to fine tune the agents or the tools that are associated with that. And that formula together takes you to what is it to go live. However, if you build these agents on Azure, then it is pay by usage, pay by number of tokens, and pay by number of tool calls. And so it just works in a very meaningful way, where you can start from zero and scale up to a particular level, and then you can look at how to optimize on costs later. Thank you for your question.
Any more questions from anyone else or anybody? So we have 5 minutes, so you can interact with our speaker if you want. If you have any query, any doubt, questions.
I mean, if you want to talk about anything other than these specific topics as well, please shoot your questions. If I do not have knowledge, I will get back to you offline through Mr. Anshuman.
Yes, definitely. So from the participant end, we expect
One more query.
yes, yes.
Excuse me, sir. Can I have one more query, sir?
Yes, Dr. Kumar.
Hello. Sir, how to manage this efficiency of this resources, sir?
Can you describe efficiency in terms of compute or storage or network, or how?
Generally, sir, resources, how do you manage through using this agentic AI system?
So if you are looking at managing the agents themselves, or you are talking about agents looking at optimized or looking at infrastructure spacing available and capacity available, and looking at the usage of your services. So there are agents that are specifically created to look at infrastructure, but if you are looking at how to manage the agents themselves and improve on their efficiency, the Cloud Foundry capabilities around. So let me try to see if I have some diagram around that. I'll just share my screen quickly to give an example of how Azure thinks of this. So this is, for example, training techniques which talk about supervised fine-tuning, or preference optimization, or reinforcement-based fine-tuning, which is a loop back to the training that you are doing, right? And based on that, you choose the right model and you try to fine-tune that model instead of starting from scratch. Now that allows you to look at if you are using the right model in context of the query that is coming in. If the query that is coming in is around research, and you are using O4 Mini, you are probably not doing research well with O4 Mini. You are doing logical tasks more appropriately with O4 Mini. So for research, you will probably use GPT 4.1, or you will use Claude, which is capable of doing far more research, right? Beyond that, there is, I think, the ability to look at serverless or managed compute. If you are using serverless, then you do not need optimization. We optimize training for speed and scalability, right? While handling all infrastructure requirements. So the optimization is done by Microsoft itself. However, the serverless will cost you, if you are using equivalent managed compute, then serverless would cost you more. But if you do not know about how much scale you need, then serverless is probably the best bet. Awesome.
Okay.
I have another meeting I need to go to, so I'm going to take your leave.
Yes. So thank you very much, Swapnil Pathare, so for your insightful talk and nice presentations. I hope all these participants enjoy this, and we'll again talk with you for further information through mail ID. And thanks to Mr. Pathare.
Thank you so much, and please hit me up on LinkedIn or on email. My email is with the faculty here in IIIT. And thank you so much for having me as a speaker. It was fun talking to you, but I wish I could get more time to build more meaningful presentation. I whacked it through a few of imported slides, but perhaps next time we can do better.
Yes. Thanks a lot. Thank you.
Thank you, Vipul.
Okay.
So good evening, all the participants. So I hope you enjoyed the first session of day 2. I was not available during the first session, but I hope you all did. We're just waiting for our speaker for the second session, Dr. Utpal, and he'll be here with us soon. Dr. Kuntal, can you hear me?
Yes, I can hear you. Yes.
Okay, great. First of all, thank you so much for accepting our invitation to give this talk to our participants. So let me just introduce you to our participants. So our participants are mainly faculties and research scholars from various institutions across the nation. And they're from a variety of fields. Some of them are from computer science and engineering, some from electronics, some even have a wider background in civil engineering and mechanical engineering. And some are also from non-engineering backgrounds. So that's our participants for you, but they're very interactive, so that's a wonderful thing to have. And to the participants, let me just introduce Dr. Kuntal to you. So Dr. Kuntal is a senior principal at Accenture Labs, Bangalore, and also an adjunct faculty professor at IIT Guwahati, and formerly he had been a part of IBM Research India at New Delhi. And Dr. Kuntal holds 250 plus granted US patents, making him one of the top 10 most prolific Indian inventors ever. He also has authored 85 plus research papers in several conferences and journals, and has served as reviewer or a member in several leading conferences and journals, including ACL and AACL, AAAI, IJCAI, and many others. At present, he acts as an area chair for the ACL rolling reviews, and Dr. Kuntal holds a PhD from IIT Delhi and a master's from IIT Bombay in computer science and engineering. So, Dr. Kuntal, I'll hand over the mic to you now. Over to you.
Thanks a lot. I really appreciate you bringing me here, and thanks for the nice introduction. So I'll get started, and thanks for also giving me a background on the audience that I have today. Because what I have is a reasonably tech-deep talk, but what I'll do is I'll restrict it to not make very tech-heavy. So what I'll do right now is I'll try to share my screen. So somehow my Teams app didn't open, so I was expecting this to open my Teams app. I'm going to a browser, so I hope that doesn't create an issue.
No, I think it will be fine. The browser will also.
Yeah, I'll also be sharing a video later on. I'll be playing a video.
Yeah, great.
But yeah, so here I am. And before I start, how much time do I have? Is it till?
We have around 90 minutes with some Q&A.
Okay, so maybe I'll go with maybe 75 minutes maybe. Maybe I'll go till 7. I'll go till 8:45, and then keep the last 15 minutes open. Or let me do this, right? While I progress, if there's any pressing question, just ask. Interrupt me.
Yeah.
And that's to the audience. And if it's just a regular question, you can head to complete the end. I'll probably try to wrap up like 15 minutes early, get 15 minutes early. 20 minutes early. Okay, so let me get started. The topic that I have today is cost and carbon. To get the laser pointer. The topic that I have today is cost and carbon management in multi-LLM environments. Okay. And this, by default, extends to AI agentic environments as well. The reason that I have this talk today is we do a lot of LLMs, GenAI, agents, GPTs, everything. But and then obviously there are the public knowledge repositories, which let's say your ChatGPT, Gemini, Perplexity, whatever, right? All of those are like trained on. And then when you take them to the corporate environment, the natural outcome is those publicly trained models have not seen what happens inside the orgs. And obviously that varies from org to org. Right? And I'm talking of orgs, but then that will also apply to its universities, that will also apply to its some confined materials, right? Private materials, for example, and confidential materials. So the point is this: you cannot use all the AI tools as is. You have to train them, and only then you can use. Now, whether you go full training, which is not very likely, or you are fine tuning. So what I heard is I've got a lot of non-CS background, so I'm trying to make things easy. And since there's a quite a bit of variety in the audience, so the background might be obvious to some, but not to others. So please keep that in mind. So I'm trying to simplify things. So when I say you have to refine the model, what I mean is if there's a multi-layer model, for example, you will have to stop. I mean, you might have to train a few layers, especially the later layers, because typically these are multi-layer models with many things happening, or later parts to speak of, right? And you can freeze the initial parts of the training, right? So your loss can propagate onto a certain depth of the network back, or you might actually destroy the entire later part of the network beyond a point and rewire the network, so to speak of, rebuild the network, right? So there are different ways you can adapt to your solution. And then there is this concept of retrieval augmented generation, RAG. which I'm sure a lot of you know about it. I don't know whether all of you do. And hence, just in summary, what happens in RAG is there are vector databases which typically encapsulate information that are specific to whatever you want to capture information for. And if I take the example of, let's say, private repositories, confidential inside organizations, confidential stuff that has not seen the world, and ChatGPTs and Geminis are not seen. So for those sort of data, you create vector databases, and when you have to do inferencing on those, you try to add additional strings based on those vector databases. So you kind of have a way to combine those to get results and retrieve data that would not have been found otherwise. I mean, I'm being extremely vague, I know, but that's probably meaningful. Now, if you notice the commonalities, there are different LLMs which is not in your control. There are different problems that need to be solved, and when you create your trained model, it's your core model, right? You cannot know, right, what it's going to solve. And if you look around the different publicly available trained models, you'll see models of all sizes, all capabilities. Like it's a 7 billion parameters, 70 billion parameters. So one is 10 times the other and bigger. So you don't even know what's the right thing for you. Which one do you choose? Right now, let's say you are taking an existing trained model, and then either want to use as is because you have got data which is publicly available. I mean, not publicly, the data might not be available, but that type of data is seen. Or you want to use on your confidential data. The question becomes, which one do you choose? How do you know this is the right model to choose? This is the right model size to choose? How do you know, right? So in this talk, I'll kind of go to that direction. But rather than just taking an LLM saying that, I'm going to take GPT 4.0. It's so great, or GPT 4.5, whatever, right? I mean, something else. The point is, these versions will keep evolving. You can always choose to take whatever is your latest and greatest support, massive models, trained on so many data. But there's a huge cost to it, and your performance might not really improve, right? And that's something I've experienced throughout. Your performance might not really improve. They might improve, they might not improve too much. The cost might be prohibitive. In fact, back in the day, right, since I work in Accenture, one of the things that we work on in the labs, and in fact in the whole of Accenture, I'm in the Accenture labs, right? But in the whole of Accenture really, is sustainable computing, sustainability, etc. In that context, the team that kind of works dedicatedly on researching sustainability, they put this example very interestingly, even before the days that these GPTs emerged, but deep learning was still around, 5 years back, let's say, 4 years back, let's say. So if you recall, typically training a deep learning model 4 years back for those who were around and for those who were not, a reasonably big data set would take 3 weeks, 4 weeks, 2 weeks, whatever. It depends on how much you want to train. Right, but grossly speaking, the models that were available then, right, in terms of what you typically train up, the parallel that we draw in sustainability is they would. I'm sorry. Can someone please go on mute? There's a lot of background noise. Sorry, but all right. Sorry, it took me some time to unmute. I couldn't unmute myself initially. And I've completely lost the track. Yes, as we went to the parallel example. So what we used to say in that team is that the cost/carbon, it was only the carbon perspective because it was sustainability, but the cost carbon that is invested towards training such a model would be 5 times, take it with a deep breath, 5 times of what a car you spend its entire lifetime. Or in other words, 5 cars you spend their entire lifetime. That much carbon. So we talk of pollution. See what a damage a full ML model can do. So if you think of training a training an LLM from scratch, you can imagine that's going to be more, right? And then there's another example of 80 trips between California and Europe. That's a massive investment. And obviously, if you are running that in your situation, you cannot imagine the volume of cost you are going to incur and carbon that you are going to give into the society, unfortunately, right? Hence, the only way to make it more sustainable, more practical, more pocket friendly is to not focus just on the quality, but also look at the cost and carbon factors and treat everything together. So sure, you need a quality, right? Nobody is asking you to really compromise on the quality. But the question is, the quality comes at what expense and how can you jointly optimize everything? So you meet your quality needs, but you really don't end up, it doesn't end up costing a fortune and you don't end up polluting the world no end. So that's the motivation of the talk. And for those who are, for those of you who have been in practice, you know, it's pretty relevant. Okay. Just my as a pointer. All right. So if I take this, and this is more from a business problem perspective, but it's true for non-business problems also, research problems, business problems whatsoever. Since this is an Accenture work, it was moved on from a business thing, and obviously I'm sharing what I can publicly share. Like the maturity comes with limitation. So okay. So see, there are different tasks like task 1, task 2, task 3, and each of those tasks can potentially be solved by multiple LLMs, right? Like LLM 1, 2, 3, right? They can maybe process text. LLM 4, 5, 6, maybe they can generate nice images. 7, 8, 9, right? Maybe for all I know, they might be generating nice videos, etc. So there are different tasks, and for each task, there are some LLMs that are known to do well. Now, selecting the right LLM in a multi-LLM environment is really important, where cost and quality of solution are key factors. Now, why is cost and quality of LLM-based solutions at all a challenge? LLMs are more power hungry than traditional models. Like I was saying, and the example that I gave of 5 lifetime cars is just a traditional deep learning model, not in an LLM, right? Now, due to the larger and more conceptually complex architectures, and therefore cost more. So this is a 2024 diagram, few months, approximately a year back, on some of the cost and number of parameters factor. Right, so I'll take a short pause here because this is beta seen and readout. So I request the audience to give a quick look at the left side diagram. And if you notice, GPT-4 is right here, massive model, massive cost. So, and so on. So Llama was actually quite in the beta, right? Among the open sources, Llama was quite better. So by the way, on this thing, the monetary costs, some are open source, which are locally hosted, and some of them are like subscription models, like software as service model. So it's not really very easy to compare across, but still whatever could be normalized here, right? So there is a need to reduce these costs, but there are a bunch of constraints or trade-offs to account for them. There's a question of accuracy, there's a question of performance, there is a question of resources, there is a question of sustainability. So there are so many things. You cannot just reduce cost and just reduce cost, right? That will take you nowhere. So what I'll do now is I'll present a paper that was done by Stanford University called Frugal GPT. That was probably beginning of 2024, maybe end of 23, right? But the philosophy still applies today, and they are very relevant. So I think it's really a good topic to bring here, and because this is one of those engineering topics which are not really too well addressed, right? So Frugal GPT was a paper for Stanford, and this picture mostly came from there. The left side, the right hand side is ours. The left side mostly came from a concept of there. So what is Frugal GPT? Frugal GPT by Stanford. So they have a theoretical framework, right? Okay. So I'll clearly call out, what are the works that they have done. Stanford had a work, Frugal GPT, that looked at cost and quality, and from an academic perspective. In Accenture Labs, we had to look at carbon also, because that's one of our additional things that we look at. And we have to also, we cannot just be in an industrial lab, we cannot just do the scientific side of things. There has to be an implementational and transition to business side also. So we have to look at that, the operationalization to speak of. Can you operationalize the Frugal GPT? And if you do, then what do you have to do? Right. So this talk is also interesting because of that. First, we cover a rigorous paper, rigorous work in a very relevant area, an area that's actually busting. And second, how do you operationalize? Now, here is a quick breaker. If you look at it, when we talk of operationalization, and in fact, Stanford also looks at that, but from an academic perspective, that you cannot train the operationalization, right? That's not an in-house thing, back-end thing. What we call testing in traditional ML, and in reality is deployment, inferencing, whatsoever. That is what you can deploy right on the ground. While the Piper example, the flight example, and so on and so forth, in those, I'm actually talking about training costs. So then how do the two things add up, right? Why on earth can I take a training and then can I take parallels of training cost and they say, oh, I reduce the inferencing costs. Why on earth? So I'll tell you why. What is a successful ML model? What's a successful, ML thing, right? ML software. A successful ML software is one that really is deployed and is operationalized at an industrial scale. Obviously, I'm talking from industry perspective, right? So I'm talking from that perspective. And ideally, anywhere between 15 to 20%, 20% is really on the higher side, it's more on 50% sides, of the lifetime of an ML model goes to training. And 85% goes to actual inferencing. Point number one. So if you look at number of operations, sure, training might be an intense thing over a few days, few weeks. But over a period of time, if I take even 20 and 80, inferencing occurs 4x, 4x times of the life cycle, so to speak of. So if I'm saving 4 cars, if I'm training and saving, if our training is equal to 5 cars, inferencing is probably 20 cars lifetime, not even 5 in the lifespan. Obviously, it's over time. It's not a 1 month cost. It's over a few years or whatsoever. But it's about 20 cars. It's not even 1 car. 5 cars anymore. Now, for those who have got ML backgrounds, I don't know whether I have that audience also here. I'm not too sure. But for those who do have, you recognize one more thing. In training, sometimes you skip. Especially in deep neural networks, sometimes you skip training some layers. When you are, let's say, doing transfer learning, you freeze some layers, like fine tuning, etc. You freeze some layers. So the training is not even a full training. In an inferencing case, it's not only you are training 80% of the time. So you are not really testing or running on the 80% of the time. That's running on the full network, right? You do not really skip, you do not hide, right? You do not drop out, etc. If you do whatever you want to do, it's not. Eventually, it's a full network, fully trained network that goes in, right? So that makes it actually even heavier. I'm just discounting that it's still 20 cars lifetime probably. So now you see, it makes actually even more sense to apply this optimization on inferencing as opposed to training. It makes sense to obviously apply on training, right? But if I have to pick one between training and inferencing, the obvious choice is inferencing. At an industrial scale, application scale, that's what makes sense in the longer run. Okay, back to the slide. Stanford optimizes over the selection of LLM APIs and prompting strategies to achieve substantial efficiency gains. So they have cost savings, they have performance and cost trade-offs.
Sir,
Yes, is there a question?
sir, your PPT is not moving, sir.
No, I'm on the same PPT. I'm just talking through right
Okay.
now. I didn't change anything.
Okay, sir.
I,
Okay.
I was not giving a background, right? I'm doing on inferencing, and what I've been so far discussing is training. So, what's the
Okay,
benefit of
sir.
doing inferencing, right? Is it inferencing or not? Is
Okay,
it
sir.
beneficial or not? Thanks.
Okay,
Yeah,
sir.
but thanks for calling out. Obviously, it could have been actually frozen. So, I really appreciate the call out. Yeah.
Okay, sir. Thank you.
So, yeah, can you see the laser pointer moving now? The laser pointer, is it moving? Can you see it moving now? Not the slide, but I'm moving the laser pointer in the screen. You know, the red dot. Okay. I'm assuming it's moving. If not, please call out again. So what Stanford did is, they took a few data sets and they took a few different kinds of, individual LLMs, right? And they had a good quality. And by the way, they had a different setup of which I'll describe in a few minutes, called Fugal GPT. And what they did is that, using Fugal GPT, they could reach the same high accuracy that the base model would provide. But look at the cost savings, massive cost savings, right? Fugal GPT, the cost of Fugal GPT was so much cheaper than the individual LLMs. I mean, in case of some text news headlines, I think it was 98.3% cheaper. Can you imagine this? So if I look at this diagram here, this figure. So with the Fugal GPT, they would pretty initially climb, and then it would plateau out here. In other words, putting heavy models was no longer beneficial. So what do they use? They use a combination of small prompts and most affordable LLMs. So they have a repository of prompts, prompt 1, 2, 3, etc., etc. They have a repository of LLMs, and obviously you can keep adding to this more and more. And this repository of LLMs has tiny LLMs, not tiny, smaller LLMs, massive LLMs. Right? So they have everything. So the question that becomes now is, how can you set this pipeline up to achieve similar results, but at a way lesser cost? So in this paper, Stanford does 5 steps. There are 5 building blocks. What are they? So these 5 actually. They have a selection where they retain a small subset of example prompts rather than a number of those. And they try to have smaller prompts which lead to a lower cost. Except the challenge that becomes is, what are the right example prompts to keep? What's a good set? Small subset that will do a good set cover. Then comes the query concatenation. Can you minimize the number of prompts by sending multiple prompts, multiple queries together? Because the invocation overheads would go down. That reduces the number of prompts and generates multiple responses that you have to segregate. Next summer, competition test. So that uses LL stores and reuses the LM API's response for smaller queries. I'm sorry, there should be a typo, it should have been LLM. So LLM API only on cache miss. So what you do is you store the previous LLM's response when there's a hit, right? And the next time you have this thing, the question is asked. The cache is reused. However, if the answer is not found in the LLM cache, then the actual LLM is invoked. So it invokes LLM only once if multiple users search for the same. See how much it saves. It saves a lot of invocations. Because quite often, the mainstream queries, the heavy queries, short queries, they are the same. And then obviously personalizations and long tails will be longer, but a lot of the queries are the same, or can be easily mapped into the same through a paraphrase detection system. Next comes what we call an LLM cascade, right? There should be a diagram on that later. But it's about employing different LLM APIs for different queries. And initially, try inexpensive LLMs that have similar or better performance earlier in the cascade. and if the inexpensive LLMs do not exhibit a good enough thing, good enough performance, then and only then follow up to the expensive LLMs. Now note this thing, if majority of the time or if sufficient number of times the small LLMs, inexpensive LLMs do not do well, then you are in trouble because you have the overhead of those plus running the bigger LLMs. But for that, what Stanford did, again, you can read up the paper. There's not enough time to explain everything if I go in this step. But what they did is they actually had a classifier which would take a text and make an estimate, reasonable estimate of whether the initial LLM will do a good job. And that estimate was mostly heuristic based, so it was quite cheap and it did quite well. Which means most of the times if you hit an expensive LLM, you already knew it's going to do well with a reasonable, reasonable confidence, and it would actually do well. Which means the overhead of invoking the lower LLMs before the bigger ones is low. So majority of the times you know that you are done with the cheap ones. Sometimes you still have to miss. So sometimes you'll be lossy in the sense first the cheap things, then the expensive ones, the heuristic would go wrong, etc. etc. But majority of the time you are okay. Which means the overhead of this pre-computation is way less than repeatedly computing over the expensive LLMs. And then comes model fine-tuning, which is using the, is pretty interesting. So what is done here is initially expensive LLMs are used because they are big, they'll probably give good answers, but the less expensive LLMs, which are reasonably aligned, they are fine-tuned with the expensive LLM responses. And then what happens is beyond a point, the inexpensive LLMs become good enough, and then that leads to more affordable AI models that just got trained over the first few queries by spending more, but then in the long term that works out. So I've given a citation of the archived version of the paper, feel free to read up. The next question is what? And I'll show the words. So in Accenture, what we have done in the Accenture Research Labs, Accenture Labs, we have created LLM control plane that operationalizes cost and quality optimization in multi-LLM environments. By the way, so we incubated this in the lab. It eventually became a product called Model Switchcode, but yeah, this is how it started off. Stanford's Fugal GPT. It provides an academic basis, like I said earlier, for implementation of frugality. So what does it teach us? It teaches that trade-offs are important. Okay, so Stanford has empirically shown that trade-offs are crucial and they can make a major difference. And the trade-offs can be in terms of cost, performance, carbon, and there could be other factors also. Next, Stanford has given mechanisms for trade-off. What are the three mechanisms? Prompt adaptation, where you minimize the prompts, you combine the prompts. LLM cascade, where you have these inexpensive LLMs, then the expensive LLMs, right? And LLM approximation, now that can be via the caching, and that can also be via training the more advanced LLMs, sorry, smaller LLMs to achieve results by guided by the more expensive, more advanced LLMs. And now what we have to do is we have to operationalize these trade-offs, which means we need to go beyond academic experiments and bake in the recommendations inside a platform that will embrace the techniques from Stanford, add novel approaches that can make it business friendly, and adapt for practical client requirements. Client being obviously industrial client. In our case, client for Accenture, but whatever you work for, if you work for. I mean, if you're not in university, you're in industry. So in the Accenture control plane, so there are a lot of things that you have to look at. Client experience, as in user experience, smart prompt advisory, right? So we have got naturally quite a few other mechanisms of making prompts better, not just concatenating, etc. Because, for example, I'll give a random example, right? You said, you tell, like you give an instruction, a prompt, save the username and password. So naturally, what we do in Accenture, we look at the context, we'll figure out it's a password, so we'll automatically augment the prompt saying, store the username, and also store the password, but with blah 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 encryption, whatever, right? Or in whatever safe digit or something, right? I cannot go into exact details, but you get the philosophy. So those sort of contextual augmentations. Then there will be an abstracted API interface, and there will be a pipeline, there will be a pipeline composition which will take care of this of the cascade. Then there's a question of observability, because in fact in the industrial scale, you cannot afford this thing to fail. So you have to make sure that these things are working well, and you have to keep monitoring. Plus, in the longer term, if you see data drift or some performance of some LLM to degrade for whatever reason, you have to also replace that LLM on the fly, or you have to update the LLM to fine tune as per the data drift, etc., etc. So those are challenges on the ground that you cannot ignore, you cannot avoid. Then comes the benchmarking of LLMs, where you look at the different LLMs and benchmark them for different things. Actually, you benchmark them for cost, you benchmark them for quality performance on standard data sets. In fact, Hugging Face has done a lot of this, but purely for the quality. Right? So a lot of it was actually available in Hugging Face, but not for the cost, not for the carbon. That was all in-house. Right? And then fine-tuning for businesses, because when you take it to a specific business, then, like I said, right, you have to take RAG on their domain or whatever, or some things might be more preferable, and then the business might have contracts with some LLMs, right, at a lower cost. So they might have pre-compute, or they might actually have have solar power supply, which means your carbon thing will really be computed differently. The cost of that will be different, etc. In fact, we have an embodiment, which is something not something I'm going to discuss, but there's this company called Electricity Maps, and then there's a very nice joint venture that we have together. But anyway, where they have a live relay of carbon. It's a public company, but when they relay the live carbon requirements, how to embed this in the system. And then there's the next generation obviously infra keeps evolving, so all of that has to be taken care of. So the role of our LLM control plane is to make Fugal GPT operable. So if you take Fugal GPT, how do you operationalize them? So there'll be this control plane which has got inferencing layer, interfacing, right? Again, two kinds of interface. One is text interface via smartphones, other is programmatic interface via APIs. Right? So all these have to be added. Then there's to be a service composition orchestration. There has to be benchmarking that tells you in terms of cost, quality, carbon for that kind of task, that kind of infra, that domain. What are known good LLMs to even start. I mean, if you start to get every single LLM for everything, you cannot do that, right? It's prohibitive, it's impractical, it takes time, it takes money, so you don't do that. You start with a heuristic and then you go from that point. And then there's fine tuning. If you take your LLM, can you fine tune to make it better on that problem? Then there's a question of internal management also. And then there's a question of governance. Right? You have to manage, you have to observe, you have to regulate. You actually have to report also for governance. So that's what the control plane comprises. So enterprise users and applications will consume, control and observe the control plane. And the control plane in turn will consume, optimize, orchestrate, control and observe the underlying layers like LLM, data, mixing, infra, and services. So I hope this vision makes sense. So this is what we prepared. So if you look at this thing, optimizing cost and carbon of enterprise LLM applications that retain the solution quality. So enterprise LLM applications incur cost and carbon across the stack. Naturally, right? So do you build from scratch, or do you buy or something, right? That typically it's for inferencing. So you can have trained models, you can do prompt engineering, then and that's what we are addressing here. And there'll be these strategies from like you have seen in Stanford Fugal GPT. And the stuff that we worked on is cost and carbon and benchmarking, and all these optimizations, and how do you dynamically configure everything, and then keep it observable and keep it controllable, right? So the how part of it, right? In the how section. The core constituents of cost and carbon management for inference in multi-LLM has these things: fine-tuning, benchmarking, cluster optimization, prompting, and this kind of goes in cycles. But ultimately, here is where it ends. Optimize. Now, so LLM benchmarking and fine-tuning enables knowing the models better. So in benchmarking, can create the benchmarks for the following. How well, in terms of quality, does a given LLM perform on a given task in a given business domain and given infra? And what's the cost impact of this? What's the carbon, sustainability, impact of this? And we had actually we had done these experiments on Intel hardware, and obviously things have moved on. When we commercialized, we went beyond. But since I'm presenting the lab work, we have taken Intel a couple of years back. Right? And along with benchmarking comes fine-tuning. So can smaller LLMs perform better? So you pick smaller, less expensive LLMs and fine-tune on given tasks for a given business domain and given infra. You benchmark the fine-tuned models for quality, cost, and sustainability. So you are still benchmarking, but after you do a fine-tuning, because after you do fine-tuning, how much does it improve? Can you now use it rather than using off the shelf? Can you take it, update, improve, and use? Right. So that's what you do. So if you look at the pipeline, the input to the pipeline is the ops parameters such as hardware type, size, latency, cost, right? And then it goes to the infra interface.
Sorry to interrupt, sir. Your slides are not looking so.
Slide is what? Which slide are you seeing right now?
Sir, the first slide only.
Oh, are you still
Yes,
seeing the first slide?
Yes, sir.
So that I didn't realize. So when I was on the slide and the complaint was raised, I was like, doing a lot of, how do you say, like, stop sharing. Okay, is it a presentation mode issue? Can you see this movement? So these are the slides I've been through. So when somebody said not moving, I was on one slide for quite some time. That was slide 3. So that was a. Is this moving when I do not go to a presentation mode? Are you seeing slide movements now?
No, sir.
I'm trying. No. Let me stop the share and restart. Are you seeing the movement now?
Yes, sir. Yes, sir. It's fine.
I don't know what was the issue. So I'm so sorry when someone said right that there's movement. I was actually on this slide for quite some time. This slide. Okay. So were you still seeing this slide only?
Yes, sir. Only the first slide was visible.
Oh my God. So then I'll try to be very short, but try to repeat some stuff because otherwise the talk becomes totally meaningless. So, okay, I'll just quickly take through, give you 5 minutes to this. First starts on the Y part. Are you seeing the Y slide? Single word, Y slide.
Yes, sir. Yes, sir. No issue. No issue.
So then I was going through this, where there are different business tasks. I have no idea what happened. How come it can get shared? So there are business problems, right? Different tasks, different LLMs that are capable of solving those. Then I was on this slide, where I'm showing this diagram, where there are open sourced, low cost API access and high cost API access models, and then the varying number of parameters. And GPT-4 was here, right up quadrant. And this mostly comes from the Stanford GPT paper, like I said. And then I was talking of looking at different constraints that needs to be looked at for realistic operationalization. Okay, I'm so sorry that that has to be redone. After that, I was looking at this thing where this table where I said you can hit the base individual LLM and have a good accuracy, but you can actually reach similar accuracy because we in fact better at some cases. And look at the cost reductions, massive cost reductions, 98.3, etc., etc. And you can do it with 2 things: smallest prompts and most affordable LLMs. And there are 3 prompts that I've seen in this repository, but obviously there can be a lot. There are 3 that I've shown here, but there can be a lot. And if you look at this, here it quickly, so this is a FugaGPT configuration. It takes something cheap, a couple of cheap things, it quickly hits a high performance, and then it hits a value, right? I mean, not 10%, it hits a value because it's already quite good. And GPT-4 is here. If you look at the performance, GPT-4 is here, so it can in fact reach the performance also. This is what I've been through. Then as we can see 5 building blocks as Stanford uses: prompt selection, concatenating multiple prompts, completion caches, where the cache, if a query was made earlier, it will be put in the cache, and next time you see a query, you fetch from there. And if it's not in the query, not in the cache, then only you invoke the LLM and return the result, but it's in the cache also possibly. Then was the LLM cascade, where you have cheaper LLMs first, inexpensive LLMs, and then the more expensive LLMs later, and then try to heuristically have a heuristics where you can guess that this query is going to do well in the cheaper one or not. And if the heuristic says yes, you first the cheaper LLM, and actually it does well, If not, if you are wrong, then you have to put to the expensive one, but then it's a relatively lesser overhead, especially if it's the cheaper one most of the times. So that was one thing. And then there's model fine tuning, which uses the responses of LLM, expensive LLMs to fine tune the less expensive LLMs. It collects powerful but expensive LLM responses to queries and fine tunes the cheaper, affordable AI models, AI as in the LLMs, right? And then the inexpensive ones become quite good. And here is a reference you can see at the bottom. Then what I was talking of is this slide. I hope my slides are moving now. Are my slides moving now? I'm on a slide where Accenture's relay control team. I just CISAs are quite sometimes in one slide now. I just mistook it for slide not moving because I was on one slide for quite some time trying to explain a concept, and that was the third slide actually. So I thought the computer was that slide is not moving, so did you use the connectivity in the middle? What I didn't realize it's not there right from the beginning. Should have checked that, my bad. And apologies for that. Anyway, so I was talking of this thing, right? So how Accenture look at these additional things for making them on the ground implementable in reality. So Stanford shows that trade-offs are important. They show how to do trade-offs, but in the Accenture labs, we have looked at some additional factors to make it operational. And then I was talking the control plane where they have to look at a lot of the factors such as client interfacing, then the interface of the client that can route to the service composition layer through textual prompts and codes, right? Abstract APIs and codes, and the whole pipe, right? Then LLM benchmarking and fine tuning, which finally sits on top of the EXL infra. And then there's vertical block that you have to govern it, manage, observe, regulate. So that's what is the control plane. So enterprise users and applications will consume, control, and observe in the control plane. And the control plane in turn consume, optimize, orchestrate, control, and observe the lower layer compositions. The composition of the elements of the lower layer, like LLM, data, mixed infra, services, everything. So then, as we're trying to show that this is the start that you work on, cost carbon, and then as on the how part. So this circular dimension as on this slide. Yeah. So I'm really hopeful that people are able to relate what I've spoken to earlier with what is being shown now. All right. So, so I was talking of two things also here, right? A is the raw benchmarks in terms of cost, quality, and carbon. And then B, fine tune the LLMs for a given task, given domain, and given business problem, given infra, whatever. And then re-benchmark. At least you can create benchmarks for certain, when you take the raw LLMs for certain domains, like you can take a raw LLM and take the healthcare domain, take finance domain, take whatever, education domain. There's so many domains, right? Infrastructure, civil, bridge making, machines, I don't know. There are a lot of people with other backgrounds than CS, and you guys obviously know a lot better than me. But the point is, if you take information from that domain and kind of benchmark, then that helps. So the input is an ops. So what's the input to the system? And that's what we are talking of. is ops parameters such as hardware type, size, speed, latency, cost, right? So this is the infra interface for LLM, and they are taken through these benchmarking processes. So what are the benchmarks? Domain task infra, accuracy and performance, which is quality. Then the domain task infra consumption cost, and domain task infra cost, but again sustainability, the terms of carbon. So you can do it with the raw LLMs, like coming from this data, right? And you can do a fine tuning and then do on those. And ideally we do for both. So there are these raw LLM providers, you know these names. And then Accenture, when we did this, we had our internal knowledge. So naturally, this is something we cannot share, but when if you are working somewhere in some industries, what I mean, or in your academic context, you would probably have your domain, your task, and some repo if you have, then you can use that. So you can again like to fine tune the model with that and then do a benchmarking. And then that benchmarking is stored in the domain task infra registry and also outputting. So that's done as an if that's requested, that's outputting. So this is the benchmarking outputs in both senses, raw benchmarks and fine-tuned benchmarks. And as I said, Hugging Face has some of these quality benchmarks. Some part of this is taken from Hugging Face in our implementation, but not all. And since we were also working on Intel as the hardware. So here are some additional things that we have looked at. So I won't go too much in depth, but the point is, on certain hardware, things should do better. In fact, at that stage, this green was some NVIDIA line, and this was doing actually better. And then if you look at this thing, so intake for GPT-J is promising, but inference is degrade compared to FP32. So for those who know, this is more of model quantization and the impact of that. So yeah, there are some layers of depth, which I won't go into too much here, but for those who know, you will figure out. So then some things were in interviews of this video response. So moving on, selecting the right LLM for the right task and composing the LLM cascade for end-to-end solution development. If I come here, then there's an LLM cascade composition component and there's an observability, which is observability is monitoring, right? So there's a monitoring and analytics component. Now in the monitoring and analytics component, we have that implementation of observability, as in monitoring of monitoring the LLM selection. LLM uses details such as duration, operations, quality, and so on. LLM cascade utilization characteristics and other important factors. It provides reports for each observed artifact. Then it performs analytics based upon the observed data. And it provides advisory on the LLM cascade configuration optimality. Right? Because that's what the output of the analytics will be. Now, if I look at the cascade composition, it's about composing the cascade, and that's a sequence of LLMs with smaller LLMs that are more likely to be successful in solving the business tasks appearing earlier in the cascade. So, what you do is there are three LLMs, let's say. The cheapest one you put first in the cascade. So, if that can solve the problem, you are done. Otherwise, slightly more expensive, and finally the most expensive one. And the cascade can be reconfigured based upon inputs from the observability and analytics component. So if your monitoring system says, analytics system says that the first LLM is no longer doing as well as before, you can replace it with something else, and so on. So what are the inputs to the system? There's a business task, and there are frugal prompts. And then obviously you get inputs from the benchmarks. Right? So LLM cascade composition comes in, and then there's a strategy, the pipeline strategy engine that selects the LLM based upon domain, task, infra, and prompt. So it combines everything, finds out what's the best, and obviously the prompt comes here, right? And then that kind of has gets it operationalized. Then there are two additional things. One is analytics and service composition advisory that will look at these inputs, and the other is that reporting, right? So this pipeline will get composed, but there will be reporting or observability, right? Monitoring and analytics, and then there will be a service composition advisory that is based upon these analytics, right? So you look at the prompts, you look at the additional insights that you have gotten by running things so far, and then there are outputs: A, the LLM usage reports, and B, LLM usage analytics and advisory. And obviously, I have also configured the LLM pipeline, which is operating inside. There's nothing to output here. Just output the configuration that can come from usage reports and so on. But here, and the third step is working on the prompts. So you can contextualize the prompt and augment the prompt. Like I was giving that username and password example, right? I mean, you save the username and password. The prompt is augmented, contextualized and augmented by saying save the username and encrypted password. Or you can even say save the username in the database, but encrypted password in the DigiLocker, something, not just password in the DigiLocker. The point is, you can automatically add context and make it a richer structure. So it contextualizes prompts, adds necessary contextual information to have the queries better aligned with business, enriched with business-driven policies, and impacting functional and non-functional requirements. The context-augmented prompts are thus more suitable to capture the business requirements in a 360-degree manner. It's not just for the user space, but you add your knowledge and eventually round it up. The other part is prompt competition simplification, which comes purely from Stanford. As you can see, contextualization and augmentation is something we do in Accenture. But we take this also naturally, right? So it has been shown that simpler prompts are this specific process, but appropriate prompt simplification does not degrade the LLM output quality. So that's something Stanford has shown, and we just take it as is. Okay. We just take their mechanism. Concatenation of multiple prompts has also been shown to be effective for plurality and without quality impact. Again, this comes from Stanford and we follow them. So we provide prompt simplification and concatenation, just following Stanford lines. But then on top of that, we apply this also. So hence, if you look at the thing, look at the pipeline, then there are client inputs, but it is taken through contextualization and augmentation, right? And then you concatenate the prompts, you simplify them, and then you send to the cache, prompt cache, right? So in a cluster, so we have like these clusters, clusters. And otherwise, it will be a notion, and so in that cluster, you send the cluster to cache to reuse the prompts. If it's found, great. If not, then you have to hit the element, and then eventually you have this output prompt. So this is different. I'm sorry. This is not the LLM prompt. So this is the prompt cache. So this is the set of prompts, similar prompts that have been cached before. So I'll tell you what the utilization of this is. The utilization of this is, if you can figure out that this prompt after augmentation and simplification is kind of exactly equal to that older prompt, then you can resend the older prompt with the textual similarity, the semantic similarity is sufficient. Send the older prompt because the next cache, which is the cache that for a moment I thought that cache, but the next cache where the solutions, the outcomes of the LLMs are stored, can be reused for that user or that set of users where results can be shared, like one client, for example. And so this is mostly it. This is how I've done the implemented the engineering. And here what I'll do is I'll take a quick stop and share a video. I've given my IDs also here. So I'll stop sharing this. I've shared my screen. What I'll do is I'll play this video. But the videos are good.
Intelligent selection of LLMs based on benchmarks.
Okay. Short pause. Was the system audio audible? Till here, I mean 5 seconds, but what was said in 5 seconds by the system. I'll play it again. I'll stop it for 6-7 seconds and see if you can hear this. The system is speaking, not me.
Intelligent selection of LLMs based on benchmarks. Enterprise.
Was this audible? Did you hear anything or was it silent?
Yes, sir, it's audible.
Audible, right? Thank you. Now I'll play this video. It's a 7-minute video, but please watch it. I hope you will be enjoying this.
Intelligent selection of LLMs based on benchmarks. Enterprises transitioning from experimentation to large-scale implementation with LLMs face challenges such as quality, increasing cost of LLM use, and their carbon impact. In diverse enterprise environments, an AI technology architect must ingest diverse benchmarking information of LLMs in the Model Hub and select suitable ones for specific use cases. The LLMs in a Model Hub can vary, including closed API access models, open source cloud models, fine-tuned reusable models, and small edge deployment models. Challenges arise in assimilating and unifying diverse information spanning across the boundaries of sources such as Hugging Face and Helm, and non-homogeneous dimensions such as quality, cost, and carbon. At Accenture Labs, we are driven to address these challenges by building intelligent tools for Model Switchboard through our innovation. By leveraging various benchmarks and generating task-specific leaderboards for LLMs, our innovation assists architects and developers in making decisions more efficiently, allowing them to focus on their core objectives rather than LLM selection. Engineered for seamless prompt routing, our innovation directs prompts to the most suitable LLM based on quality, cost, and carbon. In short, Accenture Labs research is helping address these challenges by 1. Consolidating LLM benchmarks by creating an ontology that brings together diverse information into a coherent knowledge model. 2. Developing a holistic benchmark catalog by integrating quality, cost, and carbon for LLM that can be leveraged by various roles from AI technology architects to full-stack LLM developer. 3. Streamlining LLM selection and invocation through joint optimization using multi-criteria decision analysis. We combine all the above into an innovative scoring system that recommends the optimal LLM and infrastructure for considering multiple factors and inputs. The multi-objective scoring engine takes as input the task and domain, infrastructure information, and LLM benchmarks. The engine also considers business criteria that are provided by the AI technology architect. The engine utilizes multi-criteria decision analysis, MCDA, employing an implementation called TOPSIS. The TOPSIS scores form a leaderboard from which we recommend the highest scoring LLM with associated hardware configuration. Additionally, we have developed a model selection and prompt routing APIs to simplify LLM selection and deployment by granting full-stack LLM developers greater flexibility. For example, developers can now use the APIs to direct prompts to the most suitable LLM, considering quality, cost, and carbon footprint. Our innovation pairs with Accenture's Smart Prompt Advisor, or SPA. The SPA transforms the developer prompts with context-specific information to generate quality code with fewer iterations. In a Gen AI software development environment, developers write prompts to generate code and related artifacts. Our multi-criteria LLM selection and routing engine helps the developers to route their prompts to the best LLM in the Model Hub, and then the enhanced prompt is executed, the output of which is provided to the developer. We showcase a real-life example of selecting the optimal LLM based on an input prompt from the user. In our example, the user, who is a software developer, inputs a prompt to generate JavaScript code. According to our multi-criteria LLM leaderboard, the optimal LLM identified is DeepSeek Coder 7b Instruct. However, should the developer require Python code, the optimal LLM shifts to Codelama 7b Instruct. Our APIs seamlessly route the prompt to the optimal LLM, ensuring efficient and effective code generation. In our demonstration, a prompt related to code generation is entered by a user. We enhance this prompt using SPA's assistance in generating code, which integrates code quality-related best practices, thus optimizing the prompt quality and reducing the cost and carbon footprint of the overall code generation process. Then, we get the optimal LLM for our task. If the user wishes to see how the optimal LLM is selected, he can click on the Explain button. There are various benchmarks available like Helm, proprietary benchmarks, Hugging Face, Big Code, etc. To identify the optimal LLM, we leverage MCDA to score LLMs from model hubs, considering benchmarks, prompts, tasks, and domains, alongside various infrastructures and business objectives. Subsequently, we rank the LLMs based on these scores to determine the optimal LLM. Now, the augmented prompt is routed to the optimal LLM for execution, ensuring the code generation using the optimal LLM is most suitable jointly in terms of quality, cost, and carbon for this example. This frees the developer from explicitly optimizing jointly for multiple factors, as well as from routing to different LLM APIs from different selections. Our innovation provides a seamless and unified set of APIs for dealing with a diverse and heterogeneous set of underlying LLMs. Our innovation also reports back the few other alternative LLMs that are next best in terms of overall quality, cost, and carbon. What is interesting to note is the cost and carbon metrics. The developer chooses GPT-4 to execute the code generation prompt. When executing using a raw user prompt, the generated code has a high cost and carbon value. When the prompt is optimized with SPA, high-quality code is generated and there is a significant reduction in both cost and carbon by reducing the number of interactions of LLM. Further, with our multi-criteria LLM selection engine with SPA, Code Llama 7B Instruct is selected, which is an optimal LLM from the model hub, and the code generated is of even higher quality with the reduction in cost and carbon. As demonstrated, it is possible to significantly benefit businesses by making large differences in both cost and carbon, while retaining or improving the quality of the solution of given LLM-powered apps. In our experience, this holds across business domains and tasks. Does this hold for your business too? Probably. You can find more by contacting us.
Okay, so that was mostly it. Let me quickly check if there's.
Understanding can be used.
So,
Bench.
this is like mostly new, so let me play the video here also. But before I do that, I hope you enjoyed this video, and there's the next video, right?
Intelligent LLM selection from a marketplace or a model hub.
Some of it will be common, and the philosophy is common, but it's a different visualization, so might as well it's what the
When enterprises move away from experimentation to real-world scaled implementation, various factors like cost and carbon, effectiveness of LLMs to a particular domain, etc. become important. There is no one-size-fits approach to building LLM systems. In large enterprises, this will need a plethora of LLMs that get reused across various enterprise-level or department-level use cases. As an architect, it becomes important to understand the capabilities of various LLMs available in the enterprise model hub and be able to choose the right LLM for the use case being developed. This involves ingesting diverse benchmark information from different sources and using those in a combined manner. The LLMs in an enterprise model hub can be of different kinds of API access to closed LLMs like GPT-4, open source models available for cloud or on-prem data center hosting, fine-tuned models by other departments available for reuse, small models for local edge deployment. Apart from cost of accessing these models, there must be a need to understand if available models were quantized, What kind of data was used, including etc. What it leads to is a large set of attributes describing LLMs in a model hub. Focusing on just publicly available information from sources like Hugging Face, Helm, etc., there are numerous parameters.
Ma'am, you are in mute. We are unable to hear. Ma'am, you are in mute. Unable to hear.
Hello, hello, Dr. Kuntal, you are in mute. So can you unmute yourself? Actually, we all are unable to hear you. Hello, Dr. Kuntal. Hello. Am I audible, Dr. Kuntal? You are mute, so we are all unable to hear you. Hello. Guys, there is some systems error. Maybe I am trying to contact the speaker, Dr. Dev, and then fix it out soon. Just a minute, you wait.
Okay, sir.
Hello.
couldn't hear you, ma'am.
Okay, so I've stopped the sharing for now. If needed, I'll share again. But there's some comment, and I could make out what it was. So one more acknowledgement. One more, since this is hosted by Triple IT. So the couple of videos you saw, and a lot of this material. So one of the Triple IT part-time PhD students was working till a few days back full-time in Accenture Labs, and he also played a role in Big Road actually, one of the co-researchers in the team, right? He played a lot of roles in creating this, and the videos, I think he is the one who created the videos. So that's something interesting because it has got this Triple IT also. All right, so I give it back to the audience and the moderator. I don't know if you have asked any question, you are on mute. I have not heard anything.
All the participants, please interact with our speaker, with Dr. Dey. If you have any questions, query, comment, or any kind of interactions regarding these presentations, if you have any doubt, you can interact, right? We have a couple of minutes, so you can interact. If you have any questions, you can ask.
Thanks. Okay, if there's no other question, then it might be safe to say that I can wrap up here. So what I'll do is I'll pause for a minute, sharp 1 minute. If there's no question, I'll wrap up. Obviously, with the permission of Shuman.
Yes, Dr. Dey, you may proceed on this.
So I think Dr. Anshuman, there is probably going to be another question. So if you want to take it back, please take over.
Okay, so there is no question from participant end. So then we thank to this our speaker Dr. Dey for this nice presentation, and then the sharing of a couple of information, thoughts, and the idea. It's very nice to be part of this FDP program at Triple ITZ. We many thanks to the speakers for the time and effort. So all the participants, if you have specific query regarding this talk, you can mail us so we can convey your comment to the speaker. And then again, I will thank you to all these participants and along with the speaker also. So that's all today. So also I will request to Dr. Dey so we can discuss later on for other specific information regarding this particular program through email, and also your slide you please share with us so that we can send to all these participants for their future references.
I'll share the slide. I missed the first question, comment. What was the first comment? You have two requests. One, share the slide. I'll do that. What was the other one? I missed it. So the voice is a little low at my end.
Any participant, if any participant want to query some issues regarding the topic or some questions, I may convey message to you, right?
Absolutely. You can connect the participant with me directly. That's absolutely fine.
Yes, that is the request to you.
I mean, you know, right? I mean, I enjoy.
Yes, that is right.
I'm still part of academia, despite being in the industry for the last 23 years.
Yes.
I'm almost 23 years in the industry now, so yeah. Okay, thank you so much.
Okay.
Thank you. Bye.
Okay. So thanks once again.
Thanks, bye.
Yeah. Okay, so all the participants, many thanks being a part of this FDP program. I hope all of you enjoy the talks and also the information you are gathering from the talks may really help you for future progress. So day 2 we will conclude, and then day 3 will start again tomorrow at the same schedule. And also for the attendance, I have emailed the link of Google Form where attendance and feedback and your comment and your suggestions you may post to us. Also, I have shared this link in the WhatsApp also. So please fill it up within maybe 9-10. You should complete these submissions so that we can bind up it and make a documentations further. So after that, we will not consider, after 9-10, we will not consider any more attendance. So before 9-10, you should make sure that you should submit the form properly with proper informations, whatever asked in the form. So that is the information. And regarding the program, again, we'll meet you the next day as per the schedule. So now you can ask if you have any query, questions, suggestions, comment, anything else. Couple of minutes we can discuss, or else I can conclude the session for today. No more questions, guys. So fine then. So if you don't have any questions regarding today's issues, so that's fine. So couple of time we face some kind of difficulties for technical issues, and we try our level best to resolve these issues. But I just request all of you, please join the link through browsing, not to be used any app, because sometimes you may face difficulties to join. So that is the message. Yes.
Thank you.
Yes. Okay. So then we will conclude today, and I'll see you again tomorrow as per the scheduled time. So please fill up this form I have shared through mail and a WhatsApp both, right? Before 9-10. Okay. Have a good day. Good night to all of you. Thanks. So we'll stop now.